All right, hello folks. If you have, this is part 2 to worksheet 1, Descent with Modification, which covers chapter 19. Feel free to go back to my first video. We cover questions 1 through 6. And if you have any questions about what I've said in the video, please feel free to reach out to me. You obviously know my email. I've been sending the Quizlets and it's available in the class list, so definitely don't be shy if you have any questions about anything that I've said. Alright, so we will be starting with question 7. Question 7 says, in order for a trait to be under natural selection, it must, okay, and it says circle all that apply. So A, determine the ability of an organism to capture prey. B, be heritable. C, influence the number of organisms' offspring to grow and reproduce. D, vary across the population. So if we refer back to question 2 of the worksheet, that kind of gives us some of these answers. So we can automatically circle C because one of Darwin's observations was that members of a population often vary in their inherited traits. So we can circle D, which states that traits must vary. And Darwin's inference number 2 states this unequal of ability of individuals to survive and reproduce will lead to the accumulation of favored traits in the population over generations. And so that allows us to circle number C, which states that a trait under natural selection must influence the number of organisms' offspring able to grow and reproduce. So we can circle both D and C because those were Darwin's observations and inferences. Next, we can examine B, which says be heritable. And it is clear from Darwin's observations that in order for traits to be inherited, obviously they have to be heritable, meaning that they can be passed from generation to generation. So we can say that B is true as well. And so lastly, we examine A. Determine the ability of an organism to capture prey. So while natural selection may influence traits that help an organism capture prey, it's not necessarily that natural selection determines how well an organism is going to capture prey or not. So natural selection can help influence certain traits that help predators capture prey, like talons. Certain types of talons can be passed on, etc. But it doesn't necessarily determine the ability of an organism to capture prey, right? It just can help traits be passed on that are helpful. Okay, question 8. If we found this mantis out in the wild, what might we assume about where they spend their time out in the wild? So if we're examining this picture of a mantis, we can see that this mantis is pretty colorful and it actually looks like an orchid. And so if we see this mantis out in the wild, we might assume that they spend their time maybe amongst orchids, as their skin color is going to blend in with that of a floral species, and that is ultimately going to help them avoid predators better. So pretty straightforward. Certain skin colors, I mean, you see this in chameleons, it's not just mantis, certain types of fish, right? Octopus have that ability to change their skin color with the kind of environment that they're in to blend in, to avoid predators. So we see this in a variety of species as well. It's not just mantis. Okay. Define a homologous trait and give an example. So that's question 9. A homologous trait is going to be a trait that is found in species across a range due to a common ancestor. So an example of this is four-limb bones. So four-limb bones can be found like amongst a variety of mammals, and this is not a coincidence. And this is going to indicate common ancestry amongst the mammals with the four-limb bone present. So let's say, maybe whales have this bone, and lions have this bone, and humans have this bone, right? So all of these four-limb bones across the species are going to come from a common ancestor. And so that's a homologous trait. An analogous trait. Define an analogous trait and give an example. So an analogous trait is a trait that is going to be found amongst many organisms, like the same trait or a very similar trait, but it's not due to common ancestry. It just happens to be this way because the environments that these organisms were in demanded that this trait be kind of passed on. So an example of this is you see wings in all kinds of organisms that serve necessarily one purpose, right, for flying, but they don't necessarily indicate one common ancestor. Wings were just helpful for these variety of organisms in their different environments, but that does not necessarily indicate that there is common ancestry there, that they came from one ancestor, recently at least. Okay, 11. Define what vestigial structures are and give one example. Explain how that or any vestigial structures relates to evolution. So vestigial structures, I like to call these structures leftover structures because that's what they basically are. They are kind of these structures found in organisms that were useful to the common ancestor or the ancestor at one time, but we really have no use for them. So a good example of this is tailbones. We have a tailbone. Obviously, we don't have tails now, but that's just left over from evolution. An appendix. We have no use for an appendix. It's kind of one of those organs that was useful for our ancestors, and it's still here in our bodies. It didn't get weeded out for whatever reason because it probably didn't serve some kind of problem. And so those are two examples of vestigial structures. And so the presence of these structures can indicate that a modern day organism may have hailed from a particular common ancestor. And hence they help us to kind of make connections between certain organisms and essentially draw these evolutionary relationships. Okay. 12. Anna, a fictional paleontologist, discovers fossil evidence of two species that appear very similar, but one fossil was discovered in southwestern Africa, whereas the other was discovered in northeastern South America. And a nice map was provided within the worksheet, so you can see kind of what was going on there. Describe two distinct evolutionary scenarios that would explain this oddity. We are working under the logical assumption that no one moved the fossils before Anna discovered them. What piece of missing evidence or information would you need to determine which of the two scenarios was most likely the correct explanation for her observation? So there's two kind of big explanations that would kind of explain the situation. So the first is, if we look at this map that's provided, South America and this portion of Africa are very close together, and so what likely could have happened is Millions of years ago, right, there was Pangaea, which was the giant continent, and due to the tectonic plates, they kind of moved around, and here we have separate continents, right? So the fossils, right, these organisms could have roamed all over Pangaea, and then when the organisms died and the tectonic plates kind of pulled apart and the Pangaea was separated, you have fossils in these two distinct locations. So that's one explanation. And another explanation is that the species from Western Africa or northeastern South America could have migrated and ended up in these respective places, which is why you might end up with species in both places. So there's a lot of ways that you could kind of determine what exactly happened, but one thing that you could do is carbon dating of the fossils. And so carbon dating helps us to determine basically how old fossils are, and so you can determine if the species migration was new or if the fossils are really old, and so that can kind of help you do some deductive reasoning to determine, okay, well, if this fossil is really old, it's probably from Pangaea, or if the fossils are relatively newer, then it could be because of species migration. And another thing that you could do is historical dating of those particular land masses, so you can see exactly kind of what the like how old this is and what the logical explanation for this is. However, probably the best piece of evidence would be carbon dating, because that really gives you an accurate kind of timeline for how old these fossils are going to be, and can help you make a really good assumption on what could have happened. All right, so that is worksheet 1, Descent with Modification. I will be covering worksheet 2, which deals with phylogenies, reading of phylogeny, in the next videos. And stay tuned for that. In the meantime, happy studying and stay safe and stay healthy.